All right. So in the textbook, this is section 4.5. This is the last thing in the textbook that is covered. In permutations, the order of elements matters. Okay, that is important. It does matter to us who's standing where. Or if you're coming in first, second, and third place, or if you're arranging to take a picture, where you stand matters, okay, with permutations. Password, absolutely, it matters exactly what goes when, okay? So for perms, order matter. So AB and BA are considered two possible outcomes. So you can consider these people standing for a picture. This would be two different pictures. When dealing with combinations, order does not matter, okay? When dealing with combinations, order does not matter. A and BA are considered the same outcome, okay? How do you know you're entering combinations? If you need to pick 6 numbers for the lottery ticket, like 649, you pick 6 numbers. It doesn't matter in which order you pick them in. It's just if they draw the 6 numbers you picked, you win. Okay, so that would be an example of combinations. This one is classic: choosing or selecting members for a committee. Right? This one is, and it varies slightly. Like I've seen the province ask, like they need to make a group that's going to travel to a different country to represent the school, and they've got grade 11s and grade 12s. So anyways, you're making groups where it doesn't matter the order in which you pick them in. If you're in that group with those people, then order doesn't matter. Downloading apps to your phone has shown up, so as long as you have the apps on your phone, you have them, right? Like it's all good. A hand of cards, this one is classic as well. The deck of cards is at the back of the booklet. If it comes up, you can go check it out. And the formula for combination is this. I would like you to have this on your study sheet. So it's NCR, and this is what it looks like, okay? What is the only difference between this formula and permutations? Like what has been added, like the top looks exactly the same as before. This part looks exactly the same as before. The R here is new, okay? So this is what makes combinations special, okay? Another weird variation of this, if you ever go online and Google combinations, sometimes they use this. This is, if you see NR like this surrounded by brackets, they are actually saying this. Okay, so just two different notations to say the exact same thing. So don't be worried about what's different. They're exactly the same. Look at this right-hand side. It's exactly the same. So consider Anna, Bernadette, and Clara. When it comes to permutations, so I'm going to add a little bit to it. Permutations, let's say they have to arrange in a row to take pictures. And so how many different ways can you do that? So there's 3 people, right? So you just go 3 times 2 times 1, which is also 3 pick 3, which is also 3 factorial. And that would be 6, right? 6 ways to arrange. And I will do this here real quick. So Anna, Bernadette, Clara, they can stand like this, or they can stand like this, where Bernadette and Clara are switching positions. Then you can have Bernadette up front, and then you can have A and C. You can have Bernadette in front and have CA, so you're just swapping the back, so that's already 4. You can have Clara at the front and then AB like this. You can have Clara at the front and these switched. So there are six arrangements. Okay, so that's what we've been doing so far, lots of permutations, right? Next, combinations. Okay. These three need to be in a group of 3 people. So we're using 3 people, and we have 3 people. So in a sense, you would say 3, choose 3, and what's the answer to that? Grab your calculators. I just need you to know where to find combinations. It's the same as before, so you press 3, and then you gotta go alpha window. Is it alpha window? I always forget, yes. So instead of NPR, you're gonna select NCR, and just select it, so 3, choose 3, and what is your answer? It's just 1. Okay? But I want you to use the formula. The formula calls for, if it's 3C3, you have n, which is your 3 factorial at the top. In the denominator, let me just have the formula show up at the top corner here. What's next? We have r factorial, which is, this is r. And then you have n minus r in a bracket, so that'd be 3 minus 3 factorial. If you clean that up a little bit, you get 3 factorial times 3 factorial times 0 factorial. These two will just cancel out, right? They give us 1. And what's 0 factorial? It's also just 1. So we will just get 1. So if I ask you to do this by hand, just make sure you show me using the formula. Happens it's rare that it happens. I really usually just ask you to use your calculator and figure out this. So what is this saying? This is saying that ABC is exactly the same as ACB, which is exactly the same as BCA, which is like, we're considering all of these 6 here as just 1. We're making a group of the 3, and that's all we care about. We don't care about where they're standing, if they're standing beside each other. So we're just making, you can make, right, 1 group or committee. So that's how combinations is different. Okay. In a sense, can I make you aware of this? In a sense, you're thinking, remember what we did with repeated letters? Like if we had 3 I's, what would we do? We would divide by 3 factorial, remember? So same thing here, like this situation is considering ABC as all being the same, as almost as if it's AAA, right? They're all the same. We don't care who stands where. So combinations divide out the order. They get rid of that order. They don't care about it. It's like we're not going to count the order in this case. We're just going to care about the people in the group. Let's go and try this out in an example. See how that works. So I'm going to mix it up a little bit with perms, okay? So you kind of see the contrast, hopefully. There are 12 hockey players. How many ways can a coach pick a right wing, a left wing, a center, a right defender, a left defender for her starting lineup? Do you notice that there are specific positions to be filled? It's not just how many ways can a coach pick 5 players? It has specific positions. This is permutation. Okay? Specific positions, therefore perms. Okay, this is a perms scenario. You can use perms, or you can use the fundamental counting principle as well. Like that is always an option for you. So basically, this is a right wing, left wing, center, right defender, left defender. So right wing, left wing, center, right defender, left defender. So there's specific positions to be filled. This is almost like how many ways can you go first, second, and third, or president, vice president, treasurer, and so forth. Specific positions, folks. Think of perms. So we've got 12 times 11 times 10 times 9 times 8. Or, what's the fancy way of saying this? 12 pick 5. Okay. This would be 95,040 ways that a coach can come up with different teams. And this is obviously, if you've been on a team, you don't make a left defender a forward, right? But technically you could. If you didn't care, if you just had to fill these positions, you could come up with 95,000 different, and then some, right? Ways of filling that. Contrast this with B. What if the coach just wants 5 players for his starting lineup? No positions. Okay, make a note. Note, no specific positions filled. There are no specific positions filled. Their order does not matter. Therefore, combinations. Please don't mix this up with how many combinations can you make for this lock. You know, I've talked about that earlier. Don't mix that up. A password, a lock, order always matters. Okay? For a password, order matters. You can't just say, oh, I think it's 215, any order you want. That doesn't work. Passwords are always, so don't think combinations means the same as combinations now, okay? I actually shouldn't have done that, but I know the province has used the word combinations for a password. So make a note of that maybe in your study sheet. Don't worry about it. It's still the same. So 5 players. So in this case, we would just say 12. Out of the 12 players, choose 5. So let's use our calculators for this one. So you go 12, alpha window, press 8, and just choose 5. We're only having 792 different teams. I will say teams. Order does not matter, right? So basically, I'm just going to count 5 here, right? If I just count 2, so 5. If I make a team with you 5, that's it. I just counted once. I don't care where you sit in this case, because you're going to go on the field and you're going to be the one team. That's it. Whether you skate in a different order, I don't care. Okay. If I turn this around, it's like, hey, you go on the field, you go on the skating rink and line up, we want to take a picture. All of a sudden, that turns into permutation. Because now, every picture, it matters where you stand, right? So I'm trying to contrast, what are you looking for? What are some keywords to see that? Okay. Simplify by hand. Let's do this real quick. I find these. So basically you take, this is your n, and this is the r. So n factorial, and then it calls for r factorial times n minus r factorial. So you get 8 factorial, 5 factorial, 3 factorial. Like that. Just show me as much work as possible. I want you to expand at least once and cancel something out. 8 is the greatest of all of them. So watch what I'm going to do. I'm going to go 8, 7, 6, 5. I stop. because that's going to meet the 5 factorial down here. Cancel, cancel. Maybe one more step would be 8, 7, 6. Get rid of this factorial. 3, 2, 1. And then and you know what? On the test or quiz, just type this into your calculator and tell me what it is. Like instead of actually multiplying this out, I'm going to tell you that that's 56. 56. NPR, right? This is NR. And you got to look for the formula. It calls for 10 factorial over a 10 minus 3 factorial. And that's just 10 factorial over 7 factorial. This is going to be handy. This skill is going to be handy when I throw something to you that has like 100 or something like a big number here, and you need to cancel it out because your calculator cannot figure it out. You need to break this down first. So 10, 9, 8, 7 factorial. This one is easier to do. I stop at 7 because I want to do that. And this is 9 times 8 is 72 times 10 is 720. That's how you do that. And here is, I think this is a very good skill here. I know they've done that one year. They asked students, if you see 8C5, create a word problem that would go with that expression right there. Okay? Question? Is there a mistake? Here?
No, the first, yeah, that one.
The NPR doesn't have the R. If you go back, yeah, this is a permutation. Good question. I appreciate that. Just do it. Just do it. Interrupt me. That means you're engaged. I don't mind it. What was I gonna say? Word problem. How could you make a word problem with this? I will model this for you, obviously, right? So let's say 8C5, and you're supposed to make a word problem of it. I would honestly just say make groups, make teams. Easiest one, okay? You have 8 students available. And you need to make groups of 5. I know it's very cheesy, simple, but that does the trick. You have 8 students available, and you're picking 5 at a time. You're making a team of 5 at a time, and we're going to figure out how many there are. We're done. What about this one, the 10PR, 10P3 in this case? There are 10 participants, just to not always pick on students. 10 participants. How many ways can first, second, and third place be awarded? Another option would be you have 10 participants and you need to make groups, or you need to, how many ways can you take pictures when you select 3 at a time? Okay, you're selecting 3 at a time. So you basically, if you want to have a little example, you'd be like 10 for the first place, 9 for a second, 8 for, so you kind of, I was like, oh yeah, NPR, 10 pick 3, you're picking 3 spots, right? And you're multiplying it going downwards. Okay. I don't really use the fundamental counting principle with combinations because it gets a little messy. So I just stick with this. Okay. So that's how they're different. Here you kind of assign specific places. You could also make this a picture scenario where you're taking pictures. that's fine. But just order matters, order does not matter. Okay. Maybe, you know what? You want to be specific, you don't want to risk it, you just say order does not matter. Okay? Order does not matter. Nobody in the world knows what that means except for you. Order does matter. But please write it out. Okay? I'm just right now, I want to get to more examples here with you. So let's go to 53. How many ways can you pick 3 different flavored ice cream scoops from 10 available scoops? Perms or comps? What would you say? Should be combinations. Because if you got strawberry, chocolate, vanilla, like if you go order, can I have strawberry, chocolate, vanilla? And you're going to tell me, no, I always tell them to put chocolate first. And when that's you, okay? But normally it doesn't matter, okay? Okay, order does not play a role here. Therefore, comps. So in this case, all you would say is, well, from the 10, just choose 3. And we're not going to care about which one goes first or second or third. Okay? So that answer is 120 options. Okay? Do you want me to do art? This is the best I can do. Right? So if you've got strawberry, vanilla, chocolate, let's say, that one would be exactly the same as if you had strawberry here, vanilla here, and chocolate there. They're the same cone, so we're not counting them repeatedly. That's why we need to resort to combinations. It gets rid of it considers this a repetition. Okay? All right. Given 5 juniors and 4 seniors, how many ways can teams of 4 be selected if there are no restrictions? Here you need to be a little careful. I'm breaking this up. It could have been juniors, seniors, and maybe post-grads. Right? It could have given you different categories. It doesn't matter. You figure out the total. Total would be 5 plus 4, so you've got 9. 9 are available. Okay? And remember, I didn't mention it here again, but you're making teams. Teams, classic, if there are no specific positions, just making committees, you're making groups, it's combinations. If there are no restrictions, you just go 9, choose, how big are the teams? They are 4, right? 4 at a time. So 9, choose 4. You type that into your calculator, you get 126 teams. Okay? All right. What if the question says you want a team, pay attention to this, with exactly 2 juniors on the team? Remember, teams of 4. Remember that. We were told teams of 4. What this is saying is that you need 2 juniors and what? And 2 seniors. It's implied. It's implied. You still need teams of 4, but you want exactly 2 juniors on the team. All right? So now you need to split it up. Now you need to consider the 5s and the 4s. You ready for this? To write this one out, you're going to say, from the 5 juniors, I'm going to choose exactly 2. And, it's always and with these ones, when you're making the team. From the 4 seniors, I'm going to choose 2. And what do you notice? The 5 and the 4, like I'm going to highlight these here. The 5 and the 4 give you what? The 9 total that you have, right? You have 9 in total here. 5 plus 4 is 9. So that's what you want to check. What about the 2 and the 2? They make up your team of 4. So that's a little check there. So let's figure out what that is. Very painful, but I'm going to copy paste. So copy paste is the way to go here. 5, choose 2, that is 10. So this part here is 10. And then 4, choose 2, copy paste again. 4, choose 2 is 6. So now 10 times 6, 60 teams would have exactly 2 juniors. So obviously your answer should never be greater than the very first one we did here where we had no restrictions. There's only 126 teams available to be made that are different. Okay? And so 60 of those have exactly 2 juniors in them. Can you do the next one? Can you give it a try? How many teams have exactly 3 seniors on the team? What would that mean? 3 seniors and 1 junior. That's what that is implying. Because you always need to make your team of 4, but you want to have specifically 3 seniors on it. Give it a try. See if you can muster that one. Exactly 3 seniors. So I'm thinking seniors, so I have to draw from the 4 for this one. So 4, choose 3, and from the 5 juniors, I'm going to choose 1. So again, 9 total, still making teams of 4. Got it? I want you to look at, I didn't talk about the pattern, but anyways, we'll just do this one first. So 4C3 is 4, right? 5C1 is 5. There we go. And so this is 20 teams that can be made with this criteria. Okay. Now, let's. I might even ask a few more things, but let's tackle this one. At least 1 junior is on the team. I'm asking you to use direct and indirect reasoning. I prefer this one by far. I'm going to do this one first. So indirect. Direct is you're gonna find out is way too much work. You ready? So for indirect, what you need to do is, if you want teams with at least 1 junior in it, what would you do? Total minus, what did you say, Aliyah? No juniors? Because it says at least 1 junior, so you want teams that have 1 junior or 2 juniors or more. I'm going to get rid of the teams that have no juniors in them. Would that make sense? I will say that if an exam question asks this, this is what they're usually hinting towards. Like, go the other way, right? Because I think most of us, by default, we're like, oh, let's find out 1 and 2 juniors and 3 juniors and 4 juniors, right? Like, let's do that. That's a lot of work. I can show you on my key. Actually, I don't think I have it on my key. I just have indirect because I kind of just started doing that. So total is what? The 126 here. The 126. But I'm going to show you. I'm just going to go 9C4. I did not care juniors, seniors, it doesn't matter. From the 9, I choose 4. Minus. How would we do no juniors? We would go from the 4 juniors, no, sorry, 5 juniors, right? I'm going to choose 0. I know you're going to realize that this is not necessary in a bit, just watch. And from the 4 seniors, I'm going to choose all four, because I got to make sure I have a team of four, because 0 and 4 is still 4, 5 and 4 is still 9. Okay, so this is no juniors right here. So 9C4 is 126 minus 5C0. Anybody done that already? It's going to be 1. Anything C0 is 1. If you think about it, it's kind of weird. From 5 people, choose 0, and it's 1. I know. 4 choose 4, what's that? That is also 1. So it's 1 times 1. Okay? So it's essentially 126 minus 1, which is 125 teams. So almost all teams end up having at least one junior on it. What would be the direct way of doing it? Would be 1 junior plus 2 juniors plus 3 juniors plus 4. Why does that turn into a T? Sorry. Plus 4 juniors. So you need to do every case and then add this up. I don't have the time to do that right now. Okay. I will strongly discourage you from doing this. There's a lot of room for errors, and then if you add it up, it just won't add. This is what I would suggest you do. Okay? Maybe I'll ask you to practice this out. Let me see. Is that gonna make sense? 4, 5, choose 4 is gonna be, yeah, it's gonna be a little different. What if I twist this? Add E, please, here. I hope you still have space. How many teams have at least 1 senior on the team? I'm going to ask you to try that right now. How will this change? You, instead of total minus no juniors, you will go total minus no seniors. You'll get rid of the teams that have no seniors in it, and then you're guaranteed everything else will have at least 1 or more. Okay, try that. See what you get. With you guys. That's what I get for throwing stuff at you. Total. Mine. You're gonna have to help me here. No seniors. And so the total is 126, and this would be no seniors. So 4 choose 0, and 5 choose 4. There we go. So it's 126. 4 choose anything. Choose 0 is always 1. It's always 1. And what is this? It's 5, right? We can go this way. That's no problem. 126 minus 5. So that's 121. So there's fewer teams with at least 1 senior, because there are fewer seniors overall. If you go back to your choices 5 and 4, so it makes sense that that would be the case. Let's do a deck of cards. So I'm basically telling you it's going to be something with teams or committees on the test. So, and I'll give you some practice to do yet. Let's go to 54 on the quiz. Did I say test? On the quiz, sorry. It is basically a test. 54. How many ways can a hand of 5 cards be dealt if there are no restrictions? A hand of, you think order matters? Not really, unless you're taking pictures of different hands. But in this case, if you have the ace, the king of hearts, right? If you have everything, it doesn't matter if you have them any which way. That hand is called one hand. Okay. Maybe I'll do that in a bit, not right now. So no restrictions. I think you need to know more about a deck of cards. A deck of cards has how many cards? 52. And half of them are black. Sorry, I'm going to say 26 are black and 26 are red. I'm going to give you the very basics so you have at least something. In the black side, we've got our spades and our clubs. And there are 12, right? 13. I almost know my deck of cards. And then we've got diamonds and hearts. They're red. Yeah, we did deck of cards when we did the set theory. Yeah, never mind. Yeah. And so do you have a little deck of cards in your study sheet? Did I ask you to add that? Like, I think I did. I think it's a good idea to do so. So basically, I'm running out of words here. Every suit has ace to 10, and then it's jack, queen, king. Okay, so that's where you get your 13 from. You've got 10 cards from 1 to 10, and then you've got 11, 12, 13. These are called face cards, right? So I'm just going to leave it at that for now. There are 12 face cards. That's one thing that I will add to this because the faces do matter. So if I had no restrictions whatsoever, I would just go 52, choose. In this case, you want a hand of 5 cards. So you choose 5 cards at a time. So in this case, it's a lot. It's 2,598,960 different hands that you can be dealt. Okay. You can have no black cards. Like if I said, remember, you make a hand of 5, you cannot have black cards. This is something you need to deal with. So think about it this way. We're going to say 0 black cards and what are we going to say then? We need 5 red cards, non-black cards, right? See, so every time you have them mentioning black cards, you're like, oh, well, that means I need 5 red. That's my only other option here. So we would go from the 26, we would choose 0. Okay. And from the 26 red ones, we're going to choose 5. I already told you that 26 choose 0 is always 1. 26 choose 5, I need to do that one. Oh no, 65,780. I have that on my key. Way to go. So 65,780 hands. So quite a bit less now that you're restricted to only red cards. No black cards. Therefore, only red. So I need you to think when you read these questions, like what does that also mean, right? What is a different spin that could be placed on you? Because I could say, how many hands can be drawn or can you be dealt that have only red cards? Only red cards. It's still this. It's still the same work here. Okay. What about this one? You must have at least 1 heart. How would you do this one? Total. I hope you're thinking at least total. This is a total minus something. No hearts, yes. We're going to go total minus Mr. D because he's got no heart for making us do a quiz tomorrow, right? So no hearts. And writing this out is going to be the kicker here. So I'm going to pretend we didn't answer the total part yet. We're going to go 52, choose 5. minus. When you have something here, you need to break this down. So no hearts. How many hearts do we have? 13. We're going to choose. So what needs to be here? We're going to have to choose 5 from all the other cards that are not hearts. How many is that? Do you remember, what do these two need to add up? What do they need to add up to? They need to add up to 52. Because we always have 52 cards. So this would be 39. Because you go, where do I do this without it being too messy? That's 39. Okay. So the 39 are all cards that are not hearts. So you're basically saying none of these, only from the 39 that remain. Okay, that's what you're saying. So this is 2,598,960 minus this is 1. Some teachers maybe even might not do that one. I like this one. I like to see like it's always 52. That's how we come up with the 39. So 39 choose 5. I do have that. That's 575,757. Yikes, right? Make sure you get the 7s and the 5s in the right place. That ends up being 2,014,203 hands. Aliyah, are you disagreeing with me? You disagreeing with that? Man. You too? You got a different answer, Sean? Same as that? But this is still the same? Yikes. Sorry about that. What is it? 200 and like that? Okay. That's what it is. But who cares? A bunch of hands gone, right? Who cares? I'm just kidding. You care about every hand. Let me do this here before we wrap this up. What if I asked you, ready? At least one face card. Dun dun dun. You got this. How would you do that? Write it out. Please write it out like this first, or actually do this first. Then write out your actual notation, and then give me the answer. Okay? Do that in 3 steps. This is called indirect reasoning. At least one face card. So we want to get rid of we're going to go total minus no faces. Yeah, no face cards. So this is again 52, choose 5, minus. How many face cards are there? 12, right? From those 12, we want absolute none of those. But how many are left? 40, right? Because remember, they're supposed to add up to 52 in this case. Earlier, when we had the 9, right? The 5 and the 4, it was a little easier because they told us it was 5 and 4, so we didn't have to do this much thinking here. But from the 40, we're going to choose our 5. From the remaining, these are the non-face cards. So we get 2, 5, 9, 8. Let's see if we can get this one. 12C0 is just 1. 40C5. I flipped away from my page there. I don't think I even did this one because I just threw it at you. No, I do have it. This is 658,008. Is that good? We're good? Okay. which is 1,940,952 hands. Okay. I think I'm going to stop here. I will stop here because otherwise you guys are going to kick me out of here. I'm going to say this. Go to page 56 to 58, I believe. It's a test / review of most of what we've done. There are no pathways there. If you encounter something that we haven't done, like I'll tell you. Oh, it's not 56. I changed this booklet. Sorry. Whew, good thing I checked. 62 to 64. My bad. I keep changing the booklet, and that bites me. 62 to 64. And if you come with me, I want to 62 to 64, yes. Come with me real quick. I'm just going to show you what I mean by what you haven't seen. I'll tell you already, this one right here is combination. This is it, practicing what we've just done with teams. E takes it to a little bit of a higher level where we do a lot of like at least 3 men. So you have to have 3, 4, 5. Like you have to actually do all the cases and add it up. You can put a star on it. You don't have to worry about something like that on the test. Basically, I will promise you this, only what we've done today. Stuff we've done today. That's exactly the same? No. You have to still read. I want you to think. I don't want you to just be robots, right? But just what we did today on combinations. So pathways, number of, like if you arrange letters, if there are duplicates, you need to make sure you divide that out. If you're grouping, remember you're grouping. Grouping as in, I have to be careful. Grouping as in like having to be together with someone when you're taking pictures. That kind of grouping. Don't mix them up. And I did write on the quiz, they're taking a picture, let's say, and they're together. How many ways can you now arrange it? Being together. How about not being together? Right, so that. Question? You can ask. You're fine? Okay. Passwords. License plates. Arranging for pictures. Pathways. Did I say pathways already? Yeah. Remember the one we did at the beginning where there's like 3 towns connected by roads? And then we kind of explored how many ways to get to that town at the end, but then also coming back, right? So those are classic. And then remember the pizza question yesterday? Like how many pizzas? It's just how many can you order? How many can you make? It could be pizzas, it could be outfits, it could be you name it, right? And one more warning, identical. When it's a word, you all know, okay, those are 3 I's, 2 L's, 4 M's, whatever, okay? But also be careful if I say marbles or something that looks exactly the same, like balloons. If you have 4 red balloons, you swapping those, you should not be counting those permutations. So if you have 4 identical objects, you always still divide by 4 factorial or 3 factorial if you've got 3 of them, right? So don't forget to divide out repetition. Basically go through your booklet. That's what I'm going to draw from. And then so tomorrow you write, what is it? Last period. So the sub will have the quiz, and it should be all right. I'll not make it too long because I'm not here to stay back. A sub usually takes off right away. So I'll try to keep it short-ish. If you know what you're doing, it should be fine. I think That's all I have to say. Unless there are